everyone. In this video I'm going to show you how to do the subtraction operation in binary digits. Okay. Before I start, I need to let you know these two notes. The first note is that I know that whenever you remember subtraction, you always think of the 2's complement. Okay. However, whenever you remember the 2's complement, you remember that this 2's complement is mainly used to multiply a number by -1. Okay? I do not want you to remember the 2's complement that it is a reason to convert, or it is a way to convert the addition to subtraction or subtraction to addition. Okay? Because I know that some people, whenever they remember subtraction, they remember that, yeah, we have to use the 2's complement. Whenever they have addition, yes, we have to use the 2's complement. This is partially correct. However, a lot of times people confuse themselves and solve the problem wrong if they associate the 2's complement with addition or subtraction. Okay? 2's complement has to be associated by multiplying by -1. It is not a reason for subtraction or addition. It is not a way, it is just a partial step. Okay? And I'll let you know the details in the examples that I'm going to show you today. Okay? Let's take an example. 0, okay, 1, 1, 0, 0. Okay? And I want to subtract this number from this number the following number: 0, 1, 1, or let's assume 0, 0, 1, 0, 1. Okay? So 0, 0, 1, 0, 1. Okay? So if I want to do this operation, this is a subtraction operation. Okay? And I know that whenever you have a subtraction, you are going to convert this second number to the 2's complement and then take and do the addition. Okay? So let's take this example. 0, 1, 1, 0, 0, 0, 0, 1, 0, 0. And I want to subtract the second number from the first one. Okay? So since it's a subtraction, we do not really know how to do the subtraction from the two numbers. Okay? We cannot do subtraction in binary. So that's why we want to convert this subtraction to an addition. So how do I convert that? So what I do, the steps that I follow, if you know any other steps than the steps that I'm going to explain, then you can use them. However, a lot of people got confused by shortcuts, and this is why I want you, the best thing to do to solve a subtraction problem is to follow these steps. Okay? So you write down the first number as it is, 0, 1, 1, 0, 0, and then convert the addition to a subtraction, okay? Which means that the second number is going to be the same as it is, but with a negative sign. So here I've converted the addition to the subtraction to an addition operation, okay? And thus I have associated the negative sign with the second number, okay? And this is why the 2's complement comes into the picture. 0, 0, 1, 0, 0 with a negative sign is converted to 0, 1, 1, 0, 0. That's the first number. And the second number, the 2's complement. What's the 2's complement of 0, 0, 1, 0, 0? Well, you transcribe all the bits till you reach the first one. Okay, so everything is transcribed here, okay, till you reach the first one, and then flip every bit that follows this first one. So the first bit after the first one is 0, becomes a 1, and the 0 becomes a 1. So this is the 2's complement of this number. So why did I do the 2's complement of that number? Because I have a negative sign here, okay? which is basically the same if you have taken it as a shortcut, using the shortcut method, which is just convert this number to a 2's complement. That's correct. However, in some other examples, people got very confused. Okay, so the 2's complement is what I'm going to write down here: 1, 1, 1, 0, 0, and then do the addition. 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 0 and carry 1, 1 plus 1 plus 1 is 1 and carry 1, 1 plus 1 plus 0 is 1, no, again, it's 0 and carry 1, and this is a 1 which is discarded. Okay, so the final answer becomes this number. Okay, I know that you might say, yeah, okay, so why did we do this intermediate step? It's because a lot of people get confused in examples that I'm going to show you later on. Okay, so again, what are the steps? The first step is to convert the subtraction to an addition operation. Okay, then associate the negative sign with the second number. Okay, and then after that, I need to convert this number to its 2's complement. Why? Because of the existence of this negative. Why? Because the negative is as if I'm multiplying this number by a negative 1, so I can take the 2's complement, and then I could do the addition operation normally. How did I do the 2's complement? I transcribed all the bits till I hit the first one, okay, starting from the least significant bit, of course, and then later on, after that, each bit that comes after the first one is inverted. Okay, 1, 1, 1, 0, 0. Okay, let's take another example. Right now, okay, what do I have? I have 0, 1, 1, 0, 1, 0. Okay, and then I have 1, 0, 0, 1, 1, 1. And I want to subtract these two numbers. Okay. Again, steps. 0, 1, 1, 0, 1, 0. Convert the subtraction to addition. Okay. And then associate this number 1, 1, 1 with the negative sign. Take the 2's complement. 1. Okay, so I transcribe the first one. And then every bit after that is inverted. 0, 0, 1, 1, 0. So that's the 2's complement of this number. What's the step number 3? It's 0, 1, 1, 0, 1, and 0, plus 0, 1, 1, 0, 0, 1. 0, 1, 1, 0, 0, 1. Okay? And then do the addition. 1, 1, 0, 0, and carry 1. 1 and carry 1. Right? And then 1 here and carry 0. Okay? And carry 0. Okay? So that becomes the final answer. Of course, this final answer does not make sense. Okay? Why? Because these two bits are different. Carry in and carry out of the most significant bit are different, which means that there exists an overflow. But this is out of the scope of what I'm going to explain right now. Okay? So the first thing that I want you to know is that we have converted the subtraction to an addition and associated the negative sign with the second number. Then I take the 2's complement of the second number because of the existence of this negative sign. Then after that, I have done the addition. I have done the addition, which is adding this number, which is the 2's complement, with the first number. Okay, so what about the overflow? What's the overflow? What does it say? It says basically, since the overflow is 1, okay, why is the overflow 1? Because the overflow is the XOR between these two bits, carry in and carry out, okay. Since the overflow is 1, then this means that this number is meaningless, okay. It does not really represent the subtraction of this number from that number. Why is that the case? Because this number and that number are, these two numbers cannot be, the subtraction of them cannot be represented in 6 bits. Okay? I can explain this at the end of this video. Right? So, let's take another example. Okay? At least in this example you know how exactly we do the steps. In this following example, what I'm going to show you is something where people get confused at. So I'm going to say, yeah, okay, 0, I'm going to say 0, 1, 1, 1, 0. Okay? And then I'm going to say 1, 1, 0, 1. Okay? And here I have an addition operation. Okay? People, whenever they see this 1, this logic 1, they assume that it is a subtraction operation. So what they do is that they take the 2's complement of this number, okay, and then do an addition, which is 0, 1, 1, 1, 0, 0, again, what's the 2's complement? 1, 1, 0, 0, okay, 1, 1, yes, these are not lined up correctly. 0, 0, 1, 1. Okay. Zero, 1, 1, 1, 0, 1, 0, 1, 1, 1. And I have here an addition operation. Okay. Since this is an addition operation, even if this number is a negative number, then we do not care. Why do we need to convert this number to a 2's complement? We do not have to. If this is an addition operation, then do the addition straight away. 1, 1 plus 1 is 0 and carry 1, and then 1, carry 1, 1 plus 1 is 0, carry 1, 1 plus 0 plus 1 is 0, and carry 1, and which here is a 1. Okay? So this is discarded. Right? So the final answer becomes this 5-bit signed number. Okay? So a lot of people get confused, and whenever they see, even if they see here an addition operation, they look at the second number and find it to be a negative number, and that's why they take the 2's complement. Although you should not take the 2's complement here. The 2's complement is not associated with addition or subtraction operations. Okay? A 2's complement is associated with multiplying by -1. So you do the 2's complement whenever you see a multiplication by -1. Not whenever you see a subtraction, not whenever you see an addition. Okay? So even if you see a subtraction, you might not take the 2's complement. Why? Because the 2's complement is not associated with subtraction, is not associated with addition, it's associated with the negative multiplication. Okay? So here, and that's a clear example, if you have a 1 at the most significant bit of the second number, this is not an indication, yes, it's an indication that this number is negative, but it is not an indication that we should convert this number to be a positive number. Why should I convert it? I want to subtract. It is the same as if I gave you 3 plus -5. How are you going to do this? You're going to do basically a subtraction operation. Okay? You're going to convert this addition to a subtraction. However, one of the other ways to do it is to do this addition directly. 3 and then 3 plus -5 is -2. whenever I give you an addition, even if the second number is negative, you do not convert this to positive by doing the 2's complement. If you're giving an addition operation, you do not convert the second number. Just because it's negative, you do not convert it to a positive. This is totally wrong. If you do a conversion to a positive, then this is not correct. Okay? So why do you do a 2's complement here if the second number is negative? The second number is, if you have a multiplication by -1, then this is the only reason why you want to do a 2's complement. Let me give you this other example. Okay, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0. And here we have a negative sign. Again, this number is negative, this number is negative, and we have a subtraction operation. Okay? So are you going to take the 2's complement of this number or the 2's complement of that number? Well, it doesn't work that way. We know that whenever we have a subtraction, we need to convert it first to an addition, and then convert the number that is multiplied by -1 to a 2's complement form. Okay? So not because this is a 2's complement and this is a 2's complement, then you take, not because this is a negative number and this is a negative number, you take the 2's complement. No, we need first to convert it to an addition operation. Okay? So here, this is an addition operation. The first number is transcribed as it is. Okay, I didn't change it. The second number is multiplied by -1. 1, 0, 1, 1, 0, 0. Again, what do I do? Shall I do the 2's complement of this number, or that number, or both? Actually, the second number only. The first number is not even multiplied by -1. Why should I take the 2's complement of that first number? Because it's negative? No, that's not a reason to take the 2's complement for. Okay? So 0, 1, 0, 1, 1, 0, 1. So that becomes 0, 0, 1. And then transcribe the 1, and then after that you flip the bits. So this becomes the 2's complement of this number. 1, 1, 0, 0, 1, 1. And then 0, 0, 1, 0, 1, 0. 0, 1, 0. And the operation is still addition operation. 1 plus 0 is 1. 1 plus 1. 1 plus 0 is 1. 1, 0, 0 and carry 1. 0 and carry 1, and that one is discarded. Okay, so this becomes the final answer. Okay? So this becomes the final answer. So again, just because I have a 1 here at the, it's not just because I have a 1 here at the most significant bit, that's an indication that I should take the 2's complement. Actually, it is not the case. You take the 2's complement only if you have a multiplication by a negative number. Okay? Of course, this is having multiplication by a negative number. It is a consequence of having a subtraction operation. But I do not want you to get confused by these by shortcut steps. Okay? So this is why I want you first to convert the number, to convert the operation to an addition operation, and after that you convert the number to its 2's complement. Okay? So remember that this is not an addition, this is just 2's complement of the number. Okay? So here, from here to here, we're not doing the addition operation, this is just the 2's complement of the number. Okay, and to the overflow. What is the benefit of the overflow? The overflow is for you to find out whether the number is meaningful or not. Okay? So if you have here the overflow and you want to calculate it, the overflow is basically C in XOR C out of the most significant bit. So you look at the carry in to the most significant bit. Where's the most significant bit? That's the most significant bit. And that's the carry that comes to the most significant bit. Right? And that's the carry coming out of the most significant bit. 1 XOR 1 equals 0, which means that there is no overflow. Okay? And since there is no overflow, then that's an indication that this number is meaningful. Alright? Which means that the addition of this, the subtraction of this number from that number is correct. This number is really does really represent the subtraction of this number from that number. However, if the overflow is 1, as we have seen in one of the examples, one of the previous examples, then this is an indication that this number is not really, does not really have any meaning. It's meaningless. Why? Because the subtraction of this number minus the subtraction of this number from the first number cannot be represented in 6 bits, 6 signed bits. Okay? So this is not the case here. It was the case previously in the previous example. Okay? Okay. One final example. One, 0, 1, 0, right? 1, 0, 1, 1, 0. Okay, and here we have a negative sign, right? Here we have this number is negative and this number is positive. Okay, so that's another example. Okay, we have two numbers. The first one is multiplied by a negative, and the second one is added to the first one. Okay, so how do I do this operation? Well, where is the number that is multiplied by? First of all, it's an addition operation. It's not a subtraction operation. Okay, which means that whenever we have an addition operation, we can add them directly. However, the first number is multiplied by a negative. So we need first to convert the first number by a 2's complement operation, and then after that we add it to the second number. So I'm going to just transcribe the second number as it is. 0, 1, 1, 0. Okay? While the first number, I'm going to take the 2's complement of that. 0, 1. Okay? And then flip every bit after that. 0 becomes a 1, 0, 0. 1, 0, 0. Okay? So that is the negative number that I have taken the 2's complement of. And right now it's an addition operation. Okay? 0, 0 becomes a 0. 1 plus 1 is 0 and carry 1. 1 plus 1 plus 1 is 1 and carry 1. 1, carry 0. 0, then this is a 1. Okay? Overflow. So here there's a 0. What's the overflow? Overflow equals C in XOR C out of the most significant bit. Where is the most significant bit? This is the most significant bit. Okay. The C in is 0. The C out is 0. So 0 XOR 0. Okay. Which means, okay, so this is 0 XOR 0, which is equal to 0. Alright? So there is no overflow, which means that this number is meaningful. Right? This number is really the addition of 1, 0, 1, 1, 0 to the negative of 1, 1, 0, 1, 0. Right? So, what if I have given you this as a subtraction operation? Then in that case, this number has to be a negative and a plus sign here. So the negative operation, let me actually even do it explicitly. Okay, so that's the number that we want. That's the operation that we have. Negative a number minus another number. Okay, so the 2's complement, first of all, we need to convert the subtraction to an addition. Okay, and transcribe the two numbers as they are. 1, 1, 0, 1, 0. Alright? Negative 1, 0, 1, 1, 0. So both numbers are negative. Then you need to take the 2's complement of both numbers, which means that this is going to be 0, 1, 1, 0, 0, and the 2's complement of this number is 0, 1, 0, 1, 0, okay? Transcribe them both, transcribe these 2's complements, copy them again, 0, 1, 1, 0, okay? And then 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. It's an addition operation. 0 plus 0 is 0. 1 plus 1 is 0, carry 1. 1 plus 1 is 0 and carry 1. 1 plus 1 is 0 and carry 1. 1 plus 1 and then 0. Okay? Overflow equals C in XOR C out equals, what is C in? C in is 1 and C out is 0. Then that's an XOR, which is equal to 1. So there exists an overflow, which means that this number is meaningless. Okay? This number doesn't represent the subtraction of these two numbers. Negative 1, 1, 0, 1, 0 minus 1, 0, 1, 1, 0 is not 1, 0, 0, 0, 0. Okay? And that is basically the meaning of overflow equals 1. Okay? If you have any questions, please let me know.